a power station burning coal, a colliery producing coal, and a railway running between the two, a merry-go-round train carrying coal, a ton for every foot of the train, coal moving round the circuit and round the clock, over 1 million tons a week. Just consider how we've improved on the past. In those days, all sorts of empty wagons were trundled up to the high end of the coal yard. Each one took its turn in a queue, first to be weighed empty, then loaded. No more than one wagon could be filled at a time. Coal trickled through slowly as it was produced, and if you weren't careful, a wagon could run away down the slope unless it was securely braked. Only a few full wagons at a time could be run back down the gradient. They had to be controlled by a man using a brake stick, often the same man who had loaded the wagons. The full wagons then moved to another weighhouse, where their loaded weights were recorded. A weighbill was prepared for each one, and only then could they depart for the sidings. And in the sidings, they stood and waited. They continued to wait until a railway locomotive arrived with a rake of empty wagons. The empties disappeared back up the yard to join the queue. The full wagons were taken away for delivery to a power station. On arrival, they had to wait again, this time in the power station sidings, until they could be unloaded. The discharge point could only handle a few wagons at a time, not the whole train. A dozen wagons at most would be taken forward to be emptied, usually by upturning the wagons. The empties were pushed beyond the tippler and collected for return to the sidings, where they stood once more until they were sent back to the colliery. Wagons spent most of their lives either empty or acting as storage bins. There was no continuous flow. The system, such as it was, could only cope with modest demand for electricity. But in the 1960s, demand surged. As much as 5 million tonnes a year would be required for each new coal-fired power station. With the existing system, daily deliveries of 30,000 tonnes were simply out of the question. The movement and handling of coal had to be revolutionised. Today, at the colliery, a separate track leads from the main line to a large overhead coal bunker. From here, the merry-go-round train is loaded. A high-powered locomotive pulls a set of purpose-built wagons directly to the loading point. There is no need to store wagons or break up the train. The train works as a single unit. Its wagons are loaded while on the move. The train approaches the bunker at about 3 miles per hour. Loading speed is even slower. Wagons are weighed automatically while moving, both before and after loading. Track sensors are triggered by the wheels as they pass over the weighbridge, and axle weights are signalled to a computer. Empty wagon weights are calculated and recorded automatically. Once the train clears the bunker house, the operator signals it to stop. It's a smooth stop. Every wagon is fitted with air brakes. Men with brake sticks belong to the past. The train is then recalled for loading. It reverses back through the bunker at 0.5 mile per hour, the ideal loading speed. In the past, coal was loaded into wagons only as it was produced. Any stoppage in production caused delays. Now, coal is stored in overhead bunkers, ensuring a constant supply. The operator knows precisely how much coal to load into each wagon. The bunkers can store up to 3,000 tonnes of coal. Hydraulically operated clamshell doors release the coal evenly along the length of the bunker. 4 wagons are loaded simultaneously, each holding around 32 tonnes. A full train averages close to 1,000 tonnes. As the train emerges, it passes again over the electronic weighbridge. The computer compares loaded and empty weights to calculate the exact load. An average train takes about 25 minutes to load. Including arrival and departure, turnaround time is roughly 1 hour. Then it's off to the power station. Up to a dozen collieries may serve a single power station, with as many as 30 merry-go-round trains operating over distances of 20 miles or more. Each train runs to a timetable, yet the system is flexible enough to divert trains quickly if demand changes. Trains now run at speeds of up to 45 miles per hour, far faster than the old unfitted brake trains, with greatly reduced journey times. On arrival at the power station, the train slows to 15 miles per hour and enters a loop line. This continuous track runs through the unloading point and back around the site to rejoin the main line. The train is routed onto one of two tracks above the unloading hoppers. Twin tracks allow two trains to be emptied simultaneously. The train moves forward at just half a mile per hour. As it enters the hopper house, sensors triggered by the locomotive activate the automatic unloading system. Cams release the safety catches in sequence, and trackside equipment opens the 3 pairs of bottom doors on each wagon. The coal drops freely and rapidly. The steeply sloped wagon sides ensure complete discharge, with even distribution along the hopper. 5 wagons unload at a time. The process is continuous. As the wagons emerge, both sides are inspected for wear and damage. Doors close automatically, safety catches reset, all while the train remains in motion. Within half an hour, the entire 1,000-ton load has been discharged. Once again, total turnaround time is about an hour. The train accelerates along the departure track, building up to 45 miles per hour, and runs straight back to the colliery. And so the merry-go-round goes on. Cooperation between the railways, the electricity generating board, and the coal board has paid off handsomely. Where once 200,000 wagons were needed to move 30 million tonnes, today over 60 million tonnes are carried far more efficiently by just 10,000 wagons. Now that's progress. If you've enjoyed this look at how Britain revolutionised coal transport, please give the video a like, share it with fellow railway enthusiasts, and subscribe to the channel for more railway history and industrial stories.